Okay, hello everyone. Thanks for joining us. So today we'll be speaking about a DVT validator setup. And in general, the idea of this workshop came about because Lido contributors are actively working on the community staking initiatives to increase decentralization of the Lido protocol by allowing solo stakers to join Lido as node operators. And one of these initiatives is the addition of a new module, which is basically a subset of node operators that utilizes distributed validator technology through OBOL and SSV networks implementation. So this module is currently up and running on the Haleski testnet, and we anticipate this module to go to mainnet at the beginning of the next year. And in the meantime, we are planning to have another wave of testnet also in the beginning of the next year. So the knowledge you will acquire during this workshop will be helpful in general for your development and particularly to your potential participation in the upcoming testnet. So a little bit about how our workshop will go today. So you can either just listen or follow the steps that we'll be demonstrating during this workshop. It's up to you. So you can also ask questions in the chat, which I will enable in a minute, or like leave reaction like slow down, speed up, just to ask our host to like adjust a little bit to you. And speaking about our host for today, I'm glad to introduce Eridian. Eridian is the Ethereum enthusiast and a Lido community lifeguard who is helping us with the DVT testnets and also a participant of our DVT testnet as well, and just a smart guy. So why not? Eridian, hello, happy to have you today.
Hello, hi, thanks for such a great introduction.
Yeah, are you ready to kick off our workshop?
I am, let's go for it. So I'll start sharing my screen and we can go for this. Okay, there you go. Let me just open the chat so I can follow it in case people message along the way, because I'd like to keep an eye on that. Okay, great. Hi, everyone. So as Sasha said, thank you for the introduction. I'm Eridian and I'm a Lido community lifeguard, which means I support the Lido community stakers, of which there are not very many right now, but that's changing as we speak, because the plan is that everyone involved in the simple DVT modules and in future the growing Lido community will be able to participate in some way, ideally being an operator for Lido. So let's get started. Today, the presentation is an SSV Validator setup. This is going to be from basics, just going through the SSV documentation, walking through each step, showing you exactly what you need to do, what to look out for, what to set up at each stage. And then you should be able to follow along if you want. And then I'll be setting up that there are nodes to point to. So actually you could do this on any machine, doesn't have to be a production or like a machine that can run full nodes. You can just run it along with me. These endpoints are open to the internet, so anyone can point to them and participate. So if you want to follow along, great. Also, this will be recorded and you can run through it yourself afterwards. All the links and everything you need will be in the presentation. Okay, so there we go. To start with, I'm Eridian, as I said, and my role here is to support community stakers. So if you do have any questions afterwards, please reach out, join the Lido Discord. There is a community staking channel in there where we can talk about everything related to this and the future of staking. Okay, let's go for it. So here is the agenda for today. It's going to be pretty much everything you need to run an SSV validator from start to finish. This will be the vanilla setup. There are other setups in future that I'll run through in other workshops, for example, doing it on a DApp node and things like that. But for now, it's just going to be a vanilla setup to show you how to get it working on an Ubuntu or a Linux machine. So we're going to start with the SSV Operator Setup and go through those instructions, enabling MEV and talking a bit about MEV at the moment, MEV boost and relays and builders. setting up a DKG node, which is something we'll go through, registering the operator that we've created, configuring the operator and the metadata around it, and then finally registering the validators using both existing keys that are already running, and we'll see that start testing straight away, and also how to run the DKG once you've set your operator up. So it's a full run through of everything you need for to be set up on as an SSV operator, but also everything you need to do in the current Lido simple DVT trial for SSV, and also the future ones. This is the instructions you'll follow. So if anyone's thinking, I want to be part of those future trials, or they want to learn a bit more about the one they're currently in, these are the instructions you need. Okay, let's go for it. So the first step, we're going to, let's go on step one. Step one, we're going to set up the SSV operator. So let's jump across now. Oh, did I have that? Yeah, so that QR code is a link to this documentation. So if you want to follow along with these docs, you can. And then there's also, oh, I lost it, but there's a tiny URL that we can use as well. There you go. Sasha's put it in the chat if you want to go to these docs and click on the links and follow along. Okay. So I'm going to jump across now to the demo. This is a machine that I'm working on that has everything set up, and we're going to go through the steps now. So to start with, as I said, I've got these chains running. It's on Holsky, so I've got Geth and Lighthouse. They're running just because it's the default that was used in the OBOL trial, and to keep it the same, I've used the same in this. For mainnet, it can be something different. There's some limitations around with some of the DVT clients, which can consensus and beacon nodes, execution layer and beacon nodes can be used, but just to be aware that we're using Geth and Lighthouse today. So if you want to point to these endpoints, and we'll do this later, these are open endpoints. I can put these in the chat as well for you if you want to take a note of these. I'll just, it doesn't copy across. So let me just say that, yeah, this is the URL you need. I'll keep it on the screen so you can copy it down if you need. It'll just be at the bottom there. And then you can use these for your node when you would follow along. So just to say that we've got Geth running here, it's synced, and Lighthouse running here as well, all synced. There we go. If you want to know how I set these up, I do have some docs on docs.eridianalpha.com, and that has all the information you need from an absolutely empty system, going through setting up everything you need to get to this stage if you want to follow these instructions. There are lots of other docs that show you how to set up full nodes with different clients as well. These are just the ones that I've been using, and this is the one that explains some of the things we'll be doing today, which I'll explain in more detail when we get there, but things like opening WebSocket ports specifically for SSV. There we go. So let's start at the beginning. The node setup docs for SSV, and we're just going to walk through it just as you would do if you were part of the Lido trial, or if you wanted to be an SSV operator on a normal day. This is what you would need to do. Okay, so if you want to install an SSV node, you've come to the right place. There are some system requirements. This talks about what you need to run the node. You can get away with less, particularly for the trial today. For testing this out, you can get away with less, but these would be the production minimum values that you would want. Okay, we're just going to skip down. This is saying the execution client. As I said, so this is Geth in our case, and you must enable WebSockets. Now, WebSocket connections must be enabled because that is how the SSV node connects. And as I said here in the configuration of Geth, you can see this is how you do it. You do --WS, and then you set a WebSocket port and a WebSocket address. The address, that should be, I haven't updated this. That should be 000 if you want it to go from anywhere. Now that could be better and more restricted if you know where you want it to come from, but if you're working on the same machine or something, it just allows it to come from the same machine, depending on where you put your security levels, like firewalls and router access and things like that. So you just need to make sure that WebSockets are set up here. And that's what it means when it says you must enable WebSockets. Beacon client. This is saying just set up beacon client. As I said, using Lighthouse. It recommends not using Prism in this case, but that's an open point. Okay, so there you go. This just says you need a machine to be able to SSH into, and you need to have Docker installed. Those are the requirements to get started. Okay, so So there's not a specific Ubuntu version. I'm just using Ubuntu 22.04, the long-term support version, and it works really well. Thank you for pasting those into the chat and Kit. Yeah, so there we go. So now we've got the machine set up. We're going to go through the instructions. So generating the operator key. Now, previously, if you have done this before, the operator key was you ran the generation command and it just was a plain text file that just had the operator key in it, or it just kind of spat out onto the command line. This is a bit different now. It has an encrypted key file and a password. This gives you a bit more security when you're setting up. So if we look where we are now, we've got I've got 3 folders that I've set up. So we're going to go into the operator file. And this would be, you just create this as an empty file. I've got this set up with the config YAML already in there, and we're going to go through that step by step as we do, but a bit further down. So we're going to create the operator password now. So we're just going to grab this and paste it in. And the password, you just put straight onto the command line. I'm going to keep everything simple today. Okay, there we go. And if we look, we can see there's the password file. That's what we have to do. Running down here, you can see there's this encryption Docker that runs, and this will just run directly. So as long as you've got Docker installed and you paste this command in, you see I've not had to change anything, it should just work. We're going to run that, and there you go, successfully copied to where it's going to be. So if I run Docker again, we can now see we've got the encrypted private key JSON. If we look at the encrypted private key JSON, which is what it's saying here, this is an example of what it looks like. You can see in here that there is a in here there is the public key as well, but we'll get that later. Cool. So that's what we need to do. That's the starting point. So now we've got the operator key set up. That's our operator private key. Now that's really important. That operator private key, the encrypted private key and the password are really important files. They're the ones that encrypt and decrypt the validator key shares that you'll be using, and they're used for the DKG later on. So essentially with SSV, the key shares are stored on chain, encrypted with your private key. So what that means is that if you took your encrypted password and had that stored safely, if the machine broke that you were using or anything happened, you could take that operator, that encrypted private key, move it to a different machine, and you could run it again, and it would pull down any key shares, decrypt them from the chain for you. So it's really important that you keep that safe, because that's what you need to run your operator. Okay, so here is the config file. Now this is what tells the SSV operator all the details it needs to get started. So if we look at the configuration file here, there's quite a lot of details that we can go through. So there's global settings, which is the log levels. You can set it to debug if you're asked to by SSV, if things aren't going quite right, or you can just leave it as it is. Got the database path, which again, you just leave that as it is, because that's going to save the data directly into the directory that we're currently in, and you'll see that when we start it up. The network, as you can see here, it defaults to mainnet, and we're going to have, I think maybe I need to refresh this too. That should have Holsky as an option. Nope. So that has Holsky as one of the options that we're using today. Validator options, build a proposal. We're going to start. I'll show you what I've got right now. So we're going to start as build a proposal false, and then we're going to make it true when we enable MEV in one of the steps. Okay. There you go. So you've got these ETH2 and ETH1 endpoints, and this is what was shared in the chat by Ankit. So the beacon node address is the lighthouse in this case, and that's just the HTTP API, the RPC endpoint, and then the WebSocket address starts with WS --, and that's the WebSocket address for Geth in this case. If you look down a bit more, you've got this P2P section, which allows you to customize things like your host address and your optionally to override some ports if you want to change things, use different ports if you don't want to map the defaults. These are the defaults that are set. You can just leave that commented out. And then the key store files are the ones we just created, and the paths look like this, /encrypted key JSON, /password. And then you set the metrics port and you say, this is where I want the metrics to be published on. That could be 15,000. It doesn't really matter too much for this. But I can change it anyway. So we'll set that to 15,000. Okay, cool. So that's now set up as we want it. And using network Kalesky, and we're going to save that. There you go. So some more warnings to tell you what to do. Make sure it's using WebSocket, as I said, and then you start the node. Now, we go to here, it's DKG command. So we should be able to run it just directly as it is here. So I'm going to pull this. I want this command to be slightly different. So now let's just use it exactly as it is. Let's see what happens. Okay, so this is saying Docker run restart unless stopped, and what that means is that it will keep trying to restart unless you actually tell it to stop. So some people ask, what happens if I turn my machine off once I've started it? Can I Control-C out of the console? What will happen? The answer is, as long as that restart unless stop setting is set, then it will continue to restart and to run. We give it a name, SSV_node. We give it the config path, which is what we're using. We're setting the ports, and then we're telling it where to look for all these different files: the config file, the data file, password, the encrypted private key, and then the version to use. So let's hit enter and see what happens. There we go. So it's just started up. Sorry, just have a drink. So it's just started up there, and it will happen really fast. So let's try and go back to the start. So this happened really fast because it's Holsky, so there's not a huge amount of stuff to download. Just okay, so if we go out to the very start, we'll see that it said starting SSV version 1.2, network Holsky, and there was some other information, applying some migrations, and then it starts to connect. So you can see execution client connected, consensus client connected, and it has the addresses. So this is what you're looking for at the very start. Waiting until nodes are healthy, and then it goes through it. So you can see a bunch of information, and this is when it's syncing the registry. And that means it's syncing all the events that ever happened on SSV. Because it's Holsky, there are not many, so it happens really, really fast. And then there's a bunch of warnings, some unknown things. And then you can see very quickly, the warnings don't worry, when it's starting up, don't worry too much about some of the warnings. It's just some malformed events. And there you go. That's it. Your operator is running. Oh, actually, we need to go back to the start. There, public key. So let's grab our new public key because we need this to register our operator. There you go. So that ls down to k, that's our public key that we will use. You can grab it from the encrypted private key file as well if you formatted it. You can see it's also part of the, you can just read it straight off of there, but you can grab out the logs as well if you want. Cool. So there they go. The operator is running. That's all it takes. You just run the commands pretty much as is, and there you go. You have an operator running. Okay. So let's jump back to here and see what's next. Any questions or anything in the chat? Let me know. And I'll move on to configuring and enabling MEV. So let's say you had your operator running like we have now, and it is now, once we register it later on, it would be able to accept validators, but we want to enable MEV. Now there is, so MEV is enabled, as you saw. So this, it did stop it. And then if you go back to the workshop notes, and then we look at the logs for the Docker container, you'll see that like it stopped and then immediately restarted. So that's a bit of a clunky way to do it. What I would prefer when I do it is at this start command, if you put -d at the start, it starts detached, and then you don't have that like closing opening thing. But that's just a Docker preference. You can run it fine like this, and it still will keep running in the background. It will just restart for a second, and you see it just started back up. Okay. Yeah. So we are going to stop it. So we are going to stop the container now. So we're going to click stop, and there you go, it stopped. And we're going to edit the config file. Is it config? Yeah. So we edit the config file. And all we have to do for the MEV aspect of it, configuring MEV, how to enable MEV in the SSV node, you change that to true. So just to say that, yeah, some of the bits of this like workshop are easy and should be easy because it's there's not that many configuration steps. There we go. So we're just going to set that to true, and that's almost it. But now we need to make sure the MEV is set up on our beacon node. So we're going to restart the operator, and we can just run this again. Just go start. There you go, and that's started up, and we can check that it's running now with the logs, and so many logs. But if we jump back up, you can see build proposal MEV was disabled, and then it restarted, and build proposal MEV is enabled. Okay, so you can check everything in the logs as you go as well. And that's it. So now if we jump back to our beacon node over here, I'm just gonna, that was just me watching the logs. So I have these shortcuts set up so I can see all this. This is my configuration, my Lighthouse, and I've got the environment variables at the top to make it a bit easier to read. And you can see here builder. Now, MEV Boost does work now on Holsky, but if you don't want to use MEV Boost, you can also use a relay directly. So Lighthouse, for example, has the builder option. And when you set dash builder, you normally put your MEV Boost relay. Sorry, your MEV Boost port, and MEV Boost can be connected to multiple relays. But you can also set a single relay directly in this example, Lighthouse, and it will use that instead of going through the intermediary process of MEV Boost. Now, that's not ideal in most cases because, for example, Lighthouse only allows one builder to be set. So if that one builder is MEV Boost, that's fine because then MEV Boost can connect to multiple relays. But if you use it directly like I have here, then you can only connect to one. So I'm just showing you this as like an additional thing. Also, I don't have MEV Boost running on this machine, so it's like a quick way to get this set up. So there you go. So that works. And then when you start the beacon node, you'll see it says builders enabled, and it'll say the relays or MEV Boost that it's connected to. So just to confirm that you need this, which is what it's saying here. You need, you need the connection to be on your node and on there. Cool. Okay, so you can see that's still running, and now our operator is running with MEV Boost. That was it. Okay, what's next? DKG Node. So right now with our operator setup, if we registered it and it was an operator that could be selected on the SSV web app, then people could bring keys to it and split the keys. They can either do that online through the web app for testnet, or they could do it offline and split the keys, encrypt them, and then share them out. Yes, the MEV relays is a question. If you go to this page, and then it actually says for reference, EastAker has like relays and their corresponding endpoints. So you can actually look at this list, and they're not necessarily vetted in terms of there's no one vetting them, but there is a list that shows information about them and profit sharing models and who they use and things like that. So yeah, that information is available directly there. But yeah, so that's just more information. And as Izzy said, Lido does also have specific ones used for Lido. This is just general information if you want. Yeah, DKG. So we're going to go through that now, talk about DKG. Yeah, so, oh yeah, and then I said the Titan relay, for example, to find it. It's there. Okay, so DKG, so distributed key generation. So as I was saying, the current situation is that if you went to, if someone had an existing key, they could split it to you. But another way of creating keys is this distributed key generation, and that allows you the whole key, the full key to never have actually existed. It's just created through the ceremony where everyone signs their little bit, and creates their key share directly without having to split a whole key to start with, which can be better for security because then the whole key never exists. And also for Lido's use case, it's important because the whole key cannot exist. There is no single entity that has the validator key. That's true even now with Lido's operators. They'll generate their own keys and run them and upload them to Lido. So this is how it works, and that's why DKGs are really important. So let's see how we would set that up for SSV. So we've got our operator running, so I'm just going to jump out of that and go down to here. Yes, so the question about does SSV node act as a validator? Yes, so Karen, Obol's Karen sits as a middleware, so you have execution layer, beacon node, Karen, and then you still run something like Lighthouse or Teku underneath, or Lodestar. But yes, with this, you just run the SSV client and it does all of the signing and everything. There is no additional validator client underneath. Yeah. Okay, so enabling DKG. So DKG is a separate node. So you run it as like two services, the operator node that you had before, that you saw, and then you have the DKG. You have the DKG node running separately. And the DKG node can be run anywhere. It doesn't have to be on the same machine. It can, it just has to have the same keys. It's just kind of like just signing a message. It's not really doing anything other than that. It's just signing a message to say, yes, I've generated this key share, and it pushes it back. So if you see here, these are the instructions. You need an operator ID. You don't need the operator ID. Okay. You don't need that yet. You don't need that to like, we'll go through. You don't need that to like start. You can do the DKG without it, and then we'll work. We'll set it up without it, and then when we register the operator, that's when we'll need the operator ID to go and actually put the metadata on the tool. So you need your public and private key, which is what we've just created, and the machine endpoints, which we'll go through as well. So and you must use the same keys as we've set up for that. So right now, just to make it simpler for the config, because this is the way I tested it yesterday, I'm going to copy the operator encrypted private key and put it in DKG, and just put it into DKG. And then I'm also going to copy the operator password and put it into DKG as well. So if we go into there now, you'll see that it's the same keys. I just move them. Now you could reference them and you don't do it this way, but just simplicity to have it all in one place to show exactly how it works with the commands. There you go. So there's this thing. So this is the file structure you can see here. You need your encrypted private key JSON, your password, and your operator. .yaml. We look at the operator.yaml that I've got set up here. You can see it's got the encrypted private key JSON and the password. It's got the port that's being used, which is 3030, and this needs to be open to the internet because it will be pinged. And then, yeah, that's it. It's pretty straightforward. You just copy that pretty much directly, no changes, and that's all you need. Okay, so there we go. So we're in this file now. You can see the bits that we need. I'm going to come down to here and look at this. So this is the DKG command. Again, I put -D so it detaches, so it doesn't run it directly in the foreground. Yeah, the name, the port mapping, and what to use, and just the path that's going to be used. So it's exactly this command's the same. I just added the -D so it just doesn't run in the foreground. And then if we go back to here, what's it, shorter. Okay, and then we look at the logs for this. You can see, anyway, DKG operator. There you go. So DKG operator is now running, and it's on port 30, and that's it. So again, really straightforward. You just pretty much copy and paste the instructions exactly. And if we go to our address, come on, 3030. There you go. So this shows that it works because that's what we expect. I think there is a ping. Well, that maybe works in my mind. Anyway, the 3030 shows that it works with the 404. That's what you're looking for. And then it's online. And that's it. Again, so now the DKG operator is running. We go back to the instructions, we can see we just ran that command. We had to change the path. That was the only thing that isn't like directly copy and pastable. That's why I had it in its separate little file here. But all I did was put the current path. So I just started in the file that I was in and said, use the current path, which is where I was. So that's the only change that I made there. Okay. And now we have to go and update the operator metadata, but we don't have an operator yet. So we're going to go and do that as one of the next steps. So the operator is running. I haven't had any interactions, any smart contracts, anything at all. This has all been done locally at the moment, which is great to prove that you can get this far and have everything running and working and prove that it works without any interactions with the contracts or the web app so far. Okay. So let's go back to the presentation and see what's next. Okay, let's register the operator. Okay, so if we go to app.ssv.network and we're attached and we're on Holsky. I have to make this bigger. Doesn't really work. Okay, so we are going to join as an operator and we're going to register an operator. So the ceremony for the DKG, I'm going to show as one of the later steps because the ceremony happens when I want to register a validator, which in this workshop is just going to be the last step. But that's what's I'm going to show you the two different ways of registering validators. So here we're just registering the operator to start with. We need the public key, which I wrote down before. Oh, there you go. Don't worry, that's the private key just for this demo, so it won't exist after this demo. So we're going to grab the public key, and there we go, copy that. And then we're going to set the operator. So we're going to set a 0 fee. That's what we do for the Lido symbol DBT trials. It just set a 0 operator fee. It says you can't change it again in future, so just be aware of that. And then next. And yeah, so it's a 0. Yeah, so we're just registering the operator at a 0 fee. MetaMask pops up. This is just a cost in ETH, which is some Holsky ETH. And we wait for that to happen on the transaction to go through. So this is when you would need some Holsky ETH. If you don't have some, there are Holsky faucets. I haven't shown that. This is an SSV faucet. I think there are links to Holsky faucets as well, where you can get some just a little bit to be able to do these transactions. There you go. So I'm now set up and I'm 233. And then it says, make sure you enable MEV. Cool. So we have our operator set up there, 233. That's it. We've registered the operator. There's nothing really else to do from that side. If we go back to the SSV, if we go back to the logs for the SSV node, I don't think we see anything yet, but we don't start to see anything here, but it should, something might have shown up in the logs. But anyway, so that's the operator registered now. You can see from here. So we're going to go through now and give it a validator. There's two ways to do this. I'm going to show you the first way. Now we're in this account. We could have clicked before in the menu. There was like an option to add a validator, but now we already have this like account set up. We switch between operators and validators, and we're going to, yeah, we can configure the operator first. Okay, we'll do that. So if we go back to the operator and we go to the operator, we can edit the details. And this is where we set some operator details. We could change the name. We can add a picture, give it a description. This is all optional information. It's just public information that tells people should they use you or who you are or what relays you're using, picking on this list, what clients you're using, anything about you. And then this one, the DKG endpoint. So we do need to put this because this is what will be used for the DKG later. So grab that. Oh. 3030. Okay, so just confirm 18.171.461.33. Cool. So that's important because that's what the DKG initiator later will use. So there you go. Will be 233, and then we might change it to DKG SSV workshop node, just so you can see what the change is. And then if we update this, it requires a sign, just a sign message to say this is what we're changing, and this is the DKG endpoint. There you go. And now if we look at this in the Explorer, this is the public Explorer that anyone can go and see. You'll see now that we are SSV Workshop and we have that endpoint, but we have no validators. So let's change that. Final step, register the validators. Got the SSV faucet, which we'll need for registering a validator, and then there's the rest of the information around the two different types. So if we go to the yeah, enabling DKG. Yeah, so we can, well, there are docs for this. That's what those links are for, but the docs just show pictures of the UI. So I'm just going to show you in the UI. Validators. So we're going to add a validator. We're going to add a cluster. It says you'll need some tokens and an active validator. So if we go to workshop, there we are. Wait. Is that right? Okay. Sorry, just reading the comment. Is a static public IP required to ensure the DKG always works? Yeah, I guess it could work with dynamic, like a DYDNS or dynamic hostname or something like that. It just needs to be an endpoint that is accessible. So that would work. Sorry, let me just go back a sec. That seems like, yeah, 233. Weird. Anyway. So just go back to here. So I don't know why it says 5 validators because we're brand new, so it shouldn't. Let's look for Eridian. There I am, another one. And for the sake of this, we'll just pick these first two just to show you how the payments and that all works. So we just can pick 4 for now. You could pick 7 and 10. If you scroll down, you can see these are the ones that are being used, and it highlights which of the relays that they are using. That's the idea anyway. And then it warns you about selecting unverified operators, and that's it. So we're just going to do a custom period of 30 days. So it's saying how much do you want to fund your SSV. So when you upload a validator, you have to pay these operators for doing the work for you. So when you're paying the operators, you need to you pay them in SSV, and you pay them in SSV per day or per duty, pretty much. So you need this fund. Now, some of them, as you saw before, some of the operators charged like 2.5 SSV per year, and some of them, like ours, my one charged 0. Even if they all charge 0, you still have a network fee that you have to pay for the amount of time that it's running for, and there's some liquidation collateral as well. It's per network. The operator registration is on a single contract, so it would be per network. Yeah, so there you go. So that's why you need some SSV. You just need to accept some explanations that says if you don't have enough, you get liquidated. So we're going to do the online one for now, and I'm going to show you a live validator that's currently not running, and then see if it starts running. And then, so we'll do this online, and we are going to grab this from over here. So there is a key store and key store set up just for this, and my not imaginative password for all of these. Damn. It should be the same. No? Hmm. Well, we'll see what happens. I'll try again, but yes. It might be 1, 2, 3. So I try to do the same for this to make it easier. live demos wasn't meant to be, but that was the correct password when I used it earlier. So I've experienced UI bugs before, but I'll try one more time. But if not, all this would do is show you it running. So that's a shame. Okay, well, we'll do the DKG one, and that'll we'll start with that instead. So if we want to do it offline, which we now have running, we can use the DKG ceremony. So you can see there, I just picked offline, which I guess is a bit confusing, but it's just the way the UI works right now. Generate a new DKG. You have to set the withdrawal address, which for the Lido trials will be the Lido contract, and you paste that in. I'm just taking mine for now because it's easy. And this is the initiation command. So I'll stop this, and you can run this. Let me have that running here, and then over here run this command, which is a giant command which has everything needed in it. And hopefully, if we run it, okay. So on the right, it was the initiator saying, let's trigger the DKG. And then on the left, you can see that it successfully did the DKG. And then at the end, it says, congratulations, the private key it's done. So if we, I did this in the wrong directory. There's all this, I did it in the root directory, but you get the deposit data, you get the encrypted private key, you get the key share and the password. And then this is what you would then upload here. So we can just say that, so what you would do is then take those files and go upload them directly. And then you would do the keyshare.json. But for this demo, that won't work directly because I have this on a VM running on the cloud, and I'd have to pull it down. So that won't work directly with the keys, but you can see the actual key. This is just how to upload them and to go through that process. But yes, essentially, those are the steps for uploading the keys. You would just sign the transactions, and then the keys would get split and shared. So you can see here the operator, the DKG operator, finished its duty, and now the key shares exist for the initiator, and the initiator can go back and run that, upload the keys to the beacon chain, submit them to, say, the Lido contracts, and then also split them and upload them this way. So it's secure this way because the key shares are encrypted. So when you upload it through the web app this time, it's not going to be a problem because they're already encrypted. They'll get put on chain, and then each individual operator will then pull it down. Now, where'd it go? But each of the operators will then pull it down to their node and unencrypt it with their private key, and the operator will start a testing. So there you go. That's a full run through of how that works. Yeah, there we go. I will stop there and ask if there are any questions. Okay. Questions? Consensus client, execution client already running before setting SSV, because you need the two endpoints. So yes, you need the two endpoints, and also the SSV operator it just crashes if the endpoints aren't ready, and it'll just keep restarting and restarting until the endpoints are ready. So yes, you need that to be running before you start and fully synced for it to start working. Yeah. No. So the key is the process to pull down keys from the operator manual process. No. It's all the reason you set the WebSocket endpoint, the reason for doing the WebSocket endpoint here is because this is reading the Ethereum execution layer. It's reading smart contract details. That's why the SSV node needs the WebSocket. And this allows it to read directly from the smart contract and says, oh, you have been assigned, your public key has been assigned this key share, this encrypted key share. It pulls it, it decrypts it using the private key that you have, and it starts running it straight away. So there's nothing manual. Once you've set up your operator and you set up your DKG, in theory, you should be able to walk away and it will just do it for you. In my experience, I've set this up a few weeks ago when we were testing this, and woken up the next day and the SSV team and people had submitted validators. So I was testing and running validators without any manual interaction. It's completely zero coordination. Why does the SSV node need peers, DKG or other things as well? So the DKG uses direct peers. That's why you put that massive command. I don't know if I still have it, but yeah. Let's read the massive DKG command, and you'll see. So the DKG command is saying, here's the public key, and here's their ID, and here's their IP and endpoint. So the reason the DKG doesn't need like a peer network is because it already knows who to talk to, because you've put your public your IP address and your port number for your DKG in your operator profile. That's where it pulled this from. So that's why it works. The DKG works. Now the SSV node is a P2P network. It uses the same pub/sub network as Ethereum. So it finds other clients. There are boot nodes, and it finds other participants and connects you to them through the network. So it's routed that way. So that's why you need peers. You need SSV nodes. It will be part of a P2P network, just in the same way your Ethereum node is part of a P2P network, and the gossip network and the when you perform duties, they get sent through the network in that way. I will preserve the beacon node, the endpoints I can keep running for a day or two if you want. If you want to just test against this, but also it's fairly straightforward. Holsky it's very small at the moment, in like the 10s or like 20 gigabyte size, so it's not too onerous to set up on a local machine. No, so yeah, so it doesn't need a relay like OBOL. Yeah, it just uses the P2P connections like Ethereum itself. Lots of questions. Okay, so how do validator nodes sign transactions because private key is getting split to another cluster? So the validators actually sign the transactions are actually getting signed by it's a bit like a multisig. So everything that is done by the operator is like a multisig. So there is a duty that needs to be done, say an attestation. So you sign your bit, and then say 3 other people sign theirs, and as soon as the threshold is reached, the transaction or the duty in this case becomes valid. It becomes representative of the underlying address in a wallet, or in this case a validator, and then it works. So that's how it's able to perform the duties across distributed clusters. Alternative guides to get set up. There are lots of guides, like CoinCashi has various guides for setting up Holsky chains. You can use DApp node as well. I'm on my personal machine for the Lido trial right now. I'm running the chains on a DApp node Holsky, and that works really well. So there's lots of options, lots of ways to do that. Cool. Okay, there you go. Yes. Okay, so yes, not sure what password didn't work, but it is, I have seen UI bugs where it doesn't accept it even if it's the same. So be aware of that, but because it's validating against the keys. But otherwise, yeah, it should work. You can just upload keys directly or use the DKG as you saw. So those are the 2 options, and the operator should just be running, as it will just continue to run the node. You can see there, it's when it's saying 100% all the time, that's it downloading any new events. So it's just constantly downloading the new events from the contract. So as soon as you're given a validator, it will start testing. Now, one of the neat things about SSV is because the way it works, you don't have to worry as much, say, about as much about say running two keys in the same in two different places. So this, because the operator has to be connected to an execution layer to check the smart contract, and the execution layer has to be fully synced. So if you, for example, someone asked me, well, what happens if you turned off the execution layer so it didn't know that the validator had been removed from it, and then I gave the validator to a different cluster? Wouldn't they still be signing for it? And the answer is no, because the SSV operator won't run unless the execution layer is synced. Now, you could get into like some weird fork chain scenarios, but those are like super edge case that wouldn't really happen in real life. So it does give you quite good protection around that. Now, there are questions around, would you be beneficial to run multiple keys in the same place anyway, then, as some active redundancy? But that creates problems with the network. So it would actually lead, most likely lead to like lower effectiveness for your operator. So speaking to the SSV team, it's not worth doing that, and it would be bad for the network. So if you have an SSV node and are missing attestation, it depends on geography. Sadly, the way it works is that it's first come, first signed, essentially. So with a so if you've got 4 people in a cluster and 3 people are all next to each other in Europe and 1 person's far away in Australia, that 4th person will submit their attestation, but it's less likely that it'd be more likely they'll miss the attestation because of the latency, and also because they'll be considered last, that they may not get essentially counted towards the duty, even if it did come in time. So that's something that's being worked on to make that a bit fairer, but latency is a problem with DVT, and something that's being worked on. Okay, does the SSV node directly gossip attestations, block, etc. into the Ethereum network, or through the beacon node as per normal validator? Through the beacon node, because it can't. Yeah, it does it through the beacon node, but it does it through all the beacon nodes. So if you've got like 7 people in a cluster and you all sign, it will like push from everyone's beacon node to the network, which helps with propagation, because then you've got more people shouting, this is the block, this is the attestation, and then it's seen faster by the network, which from a network that is trying to get consensus and say what's the truth, like faster and accurate is better. So it doesn't directly publish to the Ethereum network, but it does publish to its own network, and then each of the participants publish to the Ethereum network. Okay. Let's got some examples. Example, I have 64 ETH and I have to use 2 deposits and withdrawal key pairs that hold the coin. No, so yes, this is talking about like validation stuff. So the way the clusters work is that you assign, it's like you have one validator and you assign that to a cluster. Now a cluster could be 4 people, could be 7 people. That's what, if we go back to the UI for the if we go back to the UI here, the operator UI. So you can see, go back through. So if we go back to operators here, this is my operator, and when you have clusters, you can have multiple clusters, and you would put your validators to them. So you could put one to one cluster, one to another. In terms of withdrawal addresses and fee recipients and all that, that's all done per validator. So you can have full customization. You can do whatever you want with that. Okay. Cool. There we go. So I think that's everything I wanted to cover. So I'm going to go back to the presentation now and jump to the last slide. So we've got Locke saying, if your operator is unverified, does that mean that, so did you go to the UI and register the operator with the public key on one of the steps? If you go to app.ssv.network, you'll see it says register operator. And if you go through that step and publish and put your public key in at that stage, then you'll be able to sign a transaction to register the operator, and then it should become registered. If you mean verified specifically, verification is something that is, there's a VOC, the Verified Operator Council, and you have to actually like go through a process to prove who you are a little bit and say, I don't know if it's as like KYC, but it's essentially like show who you are and that you're a professional operator or that you have some standard that is met so that you are then become verified. Okay, there we go. So that was the full workshop. You saw every step you need to do up to the point where you start running the validators. But with that DKG key, as you saw, all the keys get generated and you can go and use them. So we've got the opportunity to claim an oat for this workshop. And then you're able to claim your Discord role and become part of the Lido server staking community and get involved and talk with us there. Okay, great. I think that was perfectly on the hour. So, Sasha, is there any closing comments, anything you want to say?
Yeah, just wanted to thank you for the great workshop. Thank you, Eridian. Thank you, everyone, for coming. And next week, we will have another episode of our educational series, which will be devoted to OBL Validator. So stay tuned. Yeah, thank you, everyone.
Okay, thanks, everyone. See you at the OBL one, and hopefully a future SSV one where we show DAP node and show it as even easier without any command line or any code at all. Okay, thanks very much.